Now that we've written our first program, we can reflect a little bit on what we've learned about the Java language. So first, Java is an object-oriented language that has very strict requirements about how you write programs. So first off, any .java file has to contain a class declaration. Okay? Well, we'll see later that there are also things like interfaces where that's not 100% true, but it's mostly true to say that every Java file has to have a class declaration. Likewise, any piece of code you write, say the larger method we wrote, has to be part of a class. The square root function in Java, it's part of a class called math. And we'll see later that things like global constants, those too are part of a class. The other thing we saw is that when you want to run a Java program, we have to give a main method. This is all the code that's going to run when we actually execute the program, and we declare it using public static void main string brackets args, and we'll take apart a little bit in the next lecture and in lab 1 what all this means, but for now we're just treating it as a big old blob of mystery syntax. Now the other thing we observed is that Java is a statically typed language. So what that means is that when you declare a variable or a parameter for a function, or even the return type for a method, you have to say what type it is. Likewise, expressions have a type. So if I say string x equals 5 plus 10, that 5 plus 10 has type integer, and therefore the result cannot be put in string x. Okay? And those types are permanent. Now, the most important thing about the static typing system is that whenever you try and run, or when you try to compile your programs, the compiler checks and makes sure that all the types are in agreement, and that ensures that you avoid certain types of errors, you avoid specifically type errors. So that's unlike a language like Python where the type checks are performed during execution. Okay, so let's reflect a little bit on static typing, what we might like about it and what we might not. And so ordinarily what I would do if we lived in an ideal universe, I'd ask you questions, but since you're not in my house, I can't do that. Or at least I assume you're not in my house. I mean, I guess we can check, but it'd be pretty weird if I dragged you out here in front of your own cell. No, looks clear. Although this is good. We're still kind of moving in. I see this here Travel Fox poster. I got this many years ago. It's signed. I don't really know who these guys are exactly, but yeah, Anyway. Where were we? Static typing. So, the good parts of static typing. Well, one thing that's good about it is it catches certain types of errors, making it easier on the programmer to debug their code. Another good thing is type errors can never occur. Well, I'll say almost, because kind of can. We'll see later why. But type errors can almost never occur on the user's computer. End user's computer. So for example, if you're writing an Android app, really there should be no danger of a type error reaching their phone because ideally you're not doing anything that's going to cause type errors. Okay? Another good thing, makes it easier to read and reason about code. So if I'm looking at code someone else has written, everything's got a type. It makes it easier to understand what's going on, especially when we get to bigger programs. And then finally, code can run more efficiently. So for example, no need to do expensive runtime type checks. There's other reasons when we talk, now this isn't a machine structures course. We're not going to talk about memory allocation in any great detail, but if you go on to such courses, you'll learn about why arrays that have in statically typed languages can be more efficient. Okay, but a little beyond the scope of our course. Now the bad side of static types, code have to I'll just say code is more verbose, right? I have to actually write out int and string and whatever else everywhere. And code is less general. So if we look at the larger method, this is a larger method that only works for integers. If I wanted to compare strings or even floating point numbers, like I have here 5.5, if I try running this code, it yells at me and it says, cannot do this conversion. I can't take a floating point or a so-called double and turn it into an integer. That's not allowed. Whereas in Python, that would be no problem. Okay. There is a way around this in Java called generics, and they're a fairly decent solution. They're not as good as the equivalent generics in other languages, but we'll see that there is a way out that makes things not totally hopeless. Okay, so that's just a high-level summary of some things we've learned about the Java language. So I'll just say what's next. So there's a homework 0 that you can immediately start working on. So this will give you a chance, if you've never written Java before, a chance to explore the basics on your own. Now this is not a Java class, so we're not going to sit down and carefully go through each piece of syntax. We're going to expect you to go look at reference materials, to look at example code out there, and use your prior background knowledge to get up to speed on the basics of Java. Because once you learn one language, we expect you to start being able to learn other languages very quickly. Next up, there's also a lab. Now, if you're someone actually at Berkeley taking the residential version of the course, or like the real life version, you can use the lab machines, but most people just run the code on their own computers. So Lab 1B explains how to compile and run code on your own machine, but once you are all set up, either using the lab machines or set up to run code on your own machine, what Lab 1 does is it tells you how to use our system that lets you download the starter files, it'll give you some exercises to do, and then finally to submit them. If you're someone with no prior Java experience, it would be a really good idea to do homework 0 before the lab, just so that you have some sense of what writing Java programs is all about. And then finally, in the next lecture, we'll talk a little bit about what public, static, yada yada actually means, and go a little deeper into some of the object-oriented features for Java. And that'll be basically it for the core of the Java language. And then from there, we'll start getting into some data structures and learning Java in the context of something that's important to us in the course. See you next time.